Hey class, what I thought we'd do is do the midterm exam together really fast so that we can review some of the foundational things that we're working in 121. So once I work through that midterm exam, I've posted online a quiz that goes along with the readings, which is about recursion, and a laboratory assignment, which is to redo the midterm exam. And it has a slight modification so that it's not the same exercise. It's just got a little bit more information, a little bit different stuff there. And then a short exercise on working with recursion. There's also going to be a posting in the forum where you can post questions and answers. And of course, I've got office hours, and our instructional lab assistants will have hours online on Zoom, and our SI leaders also have a schedule online, and all that information is on the Titanium page. So let's get started. What I have here and by the way, I'm trying out different types of recording. So on my 120 class, I used Linux and tried to do a screencast there. And here I'm using a Macintosh. This is just to see how the video and the audio looks like. So if you have feedback on the video quality and the audio quality, do let me know. I've got my directory here. I've essentially cloned the same work that you did over here, which I've highlighted, the CPSC 121 midterm. And I'm going to go into that directory, and it's got all the same stuff that you would have gotten when you cloned it. So what I'm going to do is open that up in my text editor. So I'm just going to open up all the HPP files, all the CPP files. I don't really need to edit the make file. I do want to read the README, and it might be good to look at the data files, but I'll look at that later. So let's open that up, and you can see it's opened up inside my text editor here. Let me just get rid of this window here. Let's start with the README. It's really important that when you have requirements for any program that you read the requirements very carefully. So in this assignment, the requirements are that we're going to be making a program called circ, C-I-R-C, and that it's going to be calculating whether or not a set of points are within or inside or outside a circle. We're going to be using the distance formula. Now that doesn't look nice in the README because it renders nicely when you look at it on the web page. So if you go to GitHub and you look at this repository in the web browser, this will render nicely to a mathematical equation. We've got a number of input files, and the input files are specified with a circle on the first line and then points on the next line. Here, I'll open that over here. I'll just select one of the files. Let's select the first one. And you can see that the first line here has 3 data points. So that's the x, the y, and the radius. And then after that, we've got the points. So, and each of the points are defined as x and y. The output of the program will be lines that look like this, where it will first define the point and say whether it's inside or outside the circle, and it will give the circle. We need to write a point class, and here's the requirements for the point class. So we need a constructor, a deconstructor, private data members, and public methods to access the data members. And the data members for the point will be the x and y coordinates. Those would be these data points right here that I've highlighted. And for the circle class, we'll need a constructor, a deconstructor, private data members. Again, those would be the x and y, the x, the y, and the radius. There I've shown in the terminal. And public data methods to access those private data members, and a method that's called distance to, which returns a float, and it takes in a point P. And we've got the formula for the distance formula right above where I said it looks kind of weird in the README here, but if you throw this in a web browser, it'll show correctly. Another thing that's not quite clear there is that if we're going to do an array of points, then the constructor for the point class can't take parameters, because when we declare an array of points, it's going to want to construct them. So if our default constructor has parameters, or it can't find a constructor that doesn't take parameters, it's going to choke on that. We'll make sure we cross that bridge. And another thing that's going to happen is with this const point P, we might get some warnings or errors when we try compiling. We'll try to cross that bridge together and figure out what's going on. So this is all information that is how it's graded and additional requirements. So why don't we get started? I think a good place to start would be, I don't know, why don't we try writing the point class first? So we see we've got point HPP here and point CPP here. That should be pretty easy to do. So why don't we go to point HPP? And we've got a nice template here. We've got our header guards. That's the if and def point HPP, pound define point HPP, and end if. So we want to put all of our code in between these 2 points here. Now, if I want to define a class, then I'm going to start with class point, and then I'll have a semicolon at the end there. Pardon me. Runny nose. And we're going to have private data members, so I'll say private. And a point has 2 data members. It's going to have an x and a y. They're of type float. Now, the reason I know it's type float because if I look at the data file, they're decimal point data. So let's take a look at that again. Yeah, that's floats. I'm going to use floats for this. I'll call them float underscore x and float underscore y. Now, here's where we get to the public part because there's nothing else that we need to define privately. And I need to define a constructor. Let's do point float x, float y, semicolon. I need a deconstructor. Don't really need to give it any parameters. I need to also do the getters and setters. So I'm going to get x, float, get y, and now I want to get the setters. The setters don't return anything, but they take something. So they'll take float x to set x, and void set y, oops, to set y. Now you might say, like, how come I'm not defining the bodies? You might have looked online and saw people writing classes where they're defining the bodies of the functions, or the methods here, right there in the HPP. We're learning how to do this by separating them out into different files. Oftentimes for small classes, we'll define it in the HPP, but for this exercise, for what we're doing in 121, we really want to exercise moving into different files. And it's always important that you put the proper header at the top of all your files. Midterm, here what my email address is. Please don't forget to do this. This is a really, really good habit to have, and I want you to do it. It's a requirement. It's not optional. So I've got my point class defined. Now I need to go implement it. What I'll do is I'll just copy this part right here and go over to point.cpp, and I'll move point.cpp right next to it. And I'm going to paste that right there. Now before I go on, I'm also going to update the header. Now, unlike what normally, if I was doing this and I was videotaping myself, I would also be compiling constantly. I'd be running over the terminal over here and typing in make to see what's going on. But because I just want, I'm pretty confident I haven't made any terrible mistakes yet, I'm not compiling. But I want you, every time you write a line or two of code, I want you to compile. It's non-negotiable. I want you to compile. So, oops. So let's get this all fixed up. And here's a nifty thing you can do. Oops. A nifty thing you could do in some text editors. I did it again. Don't know if I can do this correctly. Huh. Why is that not working? There we go. You can have multiple cursors. Now, if you've been reading the manuals I've been asking to read, you'd know how to do this. And then I can just type that in there, put the point colon colon, and get my single cursor back, and we're off to the races. So less time typing, more time programming. Now the reason I have to put point in front of it is because it's the namespace operator. I have to tell the compiler where these things belong. And now I'm going to go in there and put those braces in. So initially in the .h we prototype these methods, and now in the .cpp I'm going to define them, or in other words, implement them. And I've got everything. Oh, but I see I made a mistake. This is a very common beginner error, which is I dropped down that cursor and I put point colon colon on the wrong side. You see, it doesn't belong there. It belongs over here. So I'm going to have to fix that up because I wasn't paying attention. But it's a common mistake. I do it all the time, and I bet you do it too. So now that I got that there, I'm going to clean that up. Great. So now let's define it. Now, because I'm inside the class, I have access to the private data members. So it's totally okay for me to type it this way. Now, I don't need to say this in that case because the variable names are clear enough. Like the compiler can tell that underscore x is the private data member for the point class, and x is a parameter or a variable that's passed in as a parameter. So you don't need to use this there. Do I need to do anything for the constructor? No. But I like to put a note to myself that it does nothing, so that way I don't forget that I accidentally left it blank or something. And then we need to get the x, so we return underscore x, we return underscore y, and here we're going to set x, and here we're going to set y. Oops, wrong one. That looks about right. So now I can come over here and I can type make, and it's going to compile. I have no errors, no warnings, no errors. If I see a warning, if I see an error, I need to address them ASAP. So if I've got my point class all done, or mostly done, it's a nice scaffold for what I want to get done, I can go on to my circle class. Now, a circle class is going to look a lot like my point class, except it's got 3 data members instead of just 2. So again, I start out with the class name. In between the header guards, right, the if and def and the pound define. And let me start out by defining my private data members. Again, these are floats. And I'm just going to call them float x, float y, and that's the center, right? You can also call them cx, cy. That might be a nicer name. Why don't we do that? We'll call it cx, cy. This is less confusing because our point class already uses underscore x and underscore y. It'll keep things clear in my mind. And then r for radius. Now we can do the public data members, or public members, which would be the constructor, deconstructor, the setter, and the getter. So why don't we write that? So I got circle. This is going to take 3 parameters, so I'll say float cx, float cy, and then float r for the radius. Oh, I started implementing it. Nope, I don't want to implement it, just want to prototype. So I put a semicolon right there. We have our deconstructor, takes no parameters. What else do we need? Well, we need getters and setters, right? So I'm going to write getters and setters for each one of these. So I'll say get cx, and if I want, I can copy this, paste it 3 times, and then I can just go back and change this to be cy, and that could be r. And then I'll write the setter. So I'll say void, because the setters don't return anything. And again, I'll copy this line here and change it to be cy and set r, but I need to put parameters there, so don't forget that. So I'll say float cx. Oops. And then I'll say float cy. And then I'll say float r. Great. Is there anything else I need to add? Yeah, there is, because I've got the distance function that was part of the requirements. So distance to, and it takes a const point ampersand p. Now the ampersand p is kind of like a pointer, but it's not. It's reference. So if you don't remember what the ampersand p means, or sorry, point ampersand means, it's a good thing to review that in your textbook. And also you can bring this up during office hours. I'd be more than happy to go through a whole bunch of examples with you. Okay, so we've got this all fleshed out. Why don't we go implement this in our .cpp? So I'm just copying those lines there. I'm going to go to circle.cpp. Oh, 1 second. Let me paste this here. I forgot to do the header. So I'm going to steal the header from HPP here, and I'll paste that here. Change this. That looks nice. And then I can copy this header right into my circle.cpp. Awesome. All right. Now let's get this worked out. Didn't make that mistake this time. Got those done. Oops, too many. Made quick work of that. Now, they're not flush to the side. Indentation is super important, so I'm going to use the keyboard shortcut to just shift them all over. And then, let's save some more time. Here's another thing you can do. If you've already copy and pasted, but we need to add those braces, I'm going to go up to my Find menu. I'll do Replace, and I'm going to find all the semicolons, and I'm going to replace it with brace, new line, close brace, new line. I'll replace all. Shazam, done. Save some time. Okay, now let's implement this. So I've got underscore cx is equal to cx. Oh, I forgot the other ones. Underscore cy is equal to cy. And underscore r is equal to r. Here is the deconstructor. We do nothing. So I'll just leave a note for myself. Here's the easy one. So we get cx, so we just have to return cx. And I can just copy this line here and remember to just change it ever so slightly for these other guys here. So underscore r for that one and underscore cy for that one. Now for the setters, well, here's where I say underscore cx is equal to cx. Now remember, I don't need to use this pointer here because this is clearly different than the private data members underscore cx. And I have access to the private data member underscore cx because I'm inside the class circle. And I know that because of how I've used this namespace operator with the name circle. Okay, so let's finish up these methods here. And we need to set r. Oh, and now we have to write the distance to function. Now, if I think it's a good idea to write a little comment to myself to say distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now there is no, there's a power function in the math library, but I don't think it's necessary to use that. We can write our own quick and dirty power function right here, or square function right here. We do need to use the square root function that comes from the math library. So I'll say float square float a, and it's going to return a times a. Now we've got this handy utility function. It's not visible to anybody else because it's not in the .h file. It's only in the .cpp file, so I can use it here. And then here's where I'll calculate this. So we'll say x2 will be the point. So let's get the point values. So I'll say float x2 is equal to p dot get x, and float y2 is equal to p dot get y. Now, I'm wondering, how would it know how to access the point? It doesn't have a definition of the point. So it's really important that over here, if we want to have access to the point, we say pound include point.hpp. When I pound include that point.hpp, now it knows how to use these methods because it's told it about all the definitions in point.hpp. Let's take a quick look over here. In point.hpp, I have getX and getY for the point class. So here in circle.cpp, if I pound include that point.hpp, I'm able to use it. Now, an alternative to this is that I can move the point.hpp, the pound include, into circle.hpp. Now, the right place to do that would be outside the pound if and def. Either way, it works. One way or the other way. So I'm going to leave it in the CPP, but you can put it in the HPP. And let's see, let's finish writing this. So we've got our x2 and y2. We know our x1 and y1 is going to be our underscore x and underscore y. So let's calculate this out. So I've got x2 minus underscore x, and I need to take the square of that, and I want to add it to the square of y2 minus underscore y, because that's our y1, and I want to do the square root of that. Okay, and I'm going to say that's equal to the distance. Then I return the distance. Okay, now the square root function is part of the math library, so I need to pound include that. Otherwise, it won't know about how to get to that code. So I'll say pound include CMath. Now, notice that I'm using the angle brackets with CMath, and that's because it's a library that belongs to the compiler's system of libraries. So I use the angle brackets. Now, the point and the circle have quotes because they're part of my project. So I think I've got my circle class all done. Let's give it a compile. I made a mistake. Unknown type name point in circle.hpp. Well, let's look at this. I did include point.hpp over here. It's not complaining about a problem here. Let's look at the error again. Oh, I see what's going on. In circle.hpp on line 27, it's saying it doesn't know about point. Let's take a look at that. Oh, see, here's where I use point, but I haven't told the circle class about point. So I made a mistake. I shouldn't put point.hpp over here. I need to put that over here in circle.hpp. When I do that, it'll become usable over here when I say the word point. So let me save all my work, and let's try compiling again. More errors, but what we do is we always start with the first one. So this argument, remember, get x as type const point. This is interesting. So we might not have seen this before. Now, the reason this is coming up is if you notice here, I say that this is a const point p. This means that point p does not change in the function distance2. It's a safeguard to say it's not changing. But inside of that function, distance2, I'm calling another function, get x. Let's hop over there and take a look at this. See, this is const, meaning it's not changing. But yet inside of this function, or this method I should say, I'm calling two other methods on these lines here where it's calling methods that it can't tell whether it's const or non-const, because those methods, get x and get y, might actually be changing p. So a way that we can address this is by telling the compiler that get x and get y do not change p. The solution to this is we go over to point.cpp, and I'll put the word right here, const. That's making the body of this method const. Nothing changes. Note that when I return something here or I return something here, I don't make any changes. Now, to complete this, I need to go back to the HPP file, point.hpp, and say const here and const here. So again, I got this error message because I'm calling this method getX that belongs to p inside of a method where I've told it p is const. The compiler doesn't know if getX and getY are const or not. So the way I can fix this again is to go to point.hpp and label the body of that method as const, and then in point.cpp again label the body of the method as const. Now let's try compiling again. We got a mistake. Because I forgot in circle.cpp, here's my error. I'm using underscore y, and I decided to use underscore cx and underscore cy when I wrote my circle to say center x and center y of the circle. Easy fix. Great, everything's compiling. Okay, so I've got my circle class, I've got my point class. Now it's time to write my application, circ.cpp. This is a pretty empty program. But we got to fill out the header. Did I do the headers up here? I think I did. So I'll just steal this header. Come over here. Yeah, a really simple description is all we need. Now, I need to let's think this through. I need to first check the number of arguments. Why? Well, I need to check to make sure there's a file. Because the way we're going to run this program, and I'll demonstrate here on the command line, is to say circ and then the data file. So it's supposed to look like this. So argc will have a count of how many arguments I have. And there should be how many arguments? Well, there's 2 arguments there. So argc should be 2. I need to check that. Now, after I check that and it's correct, let's just put a comment. If wrong, warn and exit. Now, if it isn't wrong, we want to open the file and get ready to read it. Once the file is open, we know that the first line has a circle, and then all the subsequent lines have points. So we'll read the circle from the file. Then we'll loop, because it's the same operation over and over again, loop to read the points from the file. Now, as we're looping to read the points from the file, we can actually think of it this way. We're going to loop, and inside the loop, we're going to read the points from the file, and then we're going to calculate the distance. And then print out a message. Now let's go back to that README to get an example of how that message looks like. And here we've got 2 stellar examples. So I'll copy this and come back over here, and I'll just leave it as a comment to myself so I can reuse that formatting. Okay, now if we've got this nice outline, I'm looking at it, just thinking about it, going like, yeah, that's pretty good, because I'll open the file, read out the circle, create a circle object, read out all the lines, and as I'm reading the lines, I'll just print out whether it's inside or outside. Okay, now if we can't remember how to do all this, remember there's a gist. So there's a getLine demo that I posted a while ago. So I'm going to use that getLine demo. And if you don't remember what it is, let me think for a second. It's a gist. Oops, typo right there. Gist.github.com. It's me and, oh gosh, can I remember it? Let's see. It's 78110 No, it wasn't 3. It was 4. Oh, 1104. AFC. It was. Oh no, it's not. Oh, it's a 0. FB1 F0. 22E FB5. No. 4. 8FF 8A 823 6B1. I think that's the right one from memory. Not really. So we're just going to use that code right there. So argc is less than 2. Cout. Doesn't have to be really long, just something so that we know that we made a mistake. Now, if the argument is there, let's declare a file. I'm going to use an input file stream, IF stream. Input file stream, IF stream. I'm going to give it a descriptive name, input file. And then I'm going to open up that file. Now, it's not argv0, it's argv1. And I'm going to tell it I'm reading it, so iOS in. And if I open something, I've got to make sure it's open. So I'm going to check to make sure the input file is open. And if it's not, I'm going to warn and exit. There's not much else I can do if you don't give me the file. Great. Now if I look at the top, I got IOStream, but I don't have the pound include for IFstream. So that's actually pound include fstream. And with that pound included, now I know it's going to compile. So oops, and this comment should be over here. Now we want to read the circle from the file. I know that the circle if we look at the file here, it's 3 floats, one after the other. I can use getLine, but I don't need to. Instead, I can just use floating point variables with I forget what it's called, the insertion operator, selection operator. It's the double angle brackets. I can use that to read the values. So let me define some floating point variables. So I'll say float cx, cy, and r. Those would be the variables there for the reading in the values for the circle. I've got my input file, and I'll just do that double angle bracket into cx. Double angle bracket into cy. And double angle bracket into r. Now that I have that, I can define my circle because I've got all the data I need. So I need cx, cy, and r. Great. Define my circle. All right, now I need to do the loop for the points. So let's think about this for a second. I need to know how many points do I need to input? Well, I know by definition there's always going to be 10 points here. So why don't we create a const variable right over here. I'll say const int n points, and that's going to be 10. And I can use that to control my loop as well as to declare my array. And here for the looping part, I'll put my code a little further down. I'm going to have an array of points. So I'll say point. I'll just say points. And I'll say and points. And then I need some floats to read the x. And I need a float to read the y. Now I could reuse cx, cy, but it doesn't really matter. And then I need to write my loop. So I'll say for int I is equal to, come on, I is less than n points, I plus plus. So now we're going to go from 0 up to 10, but not including 10. And for each one of these things, I'm going to pull in from the input file the x value. And I'm also going to pull in the y value. And here's where I can say points I dot set x, x, and points I set y, y. So I've got those two set, and now here's where I can do my calculations. But before I do that, let me make a quick compile. Let me see if I made any mistakes. Okay, so this is the error. I always want to start with my first error, line 49. So if I look at that, that's right here. And what's wrong with that line? Well, it says error no matching constructor for initialization of point bracket 10 bracket. And then it gives us information about what we have available to us. And it tells us the only constructor I have requires 2 parameters. Here I am making an array of 10 points. And the compiler can't identify a constructor which it can use to make that array. So what it's essentially saying is you need a constructor without any parameters. So I'll come back over to point.hpp, and I'll just add another constructor with no parameters. I'll come back to the point.cpp, and I'll make myself a constructor with no parameters. Now, what is it going to set underscore x and underscore y to? Doesn't matter, it's garbage. I don't expect to have it set it to anything. So I can set it to some value like -1 or 42 or whatever I like, or I can just ignore it for now, come back over here and say, does this address the compiler's problem? And yes, it does. Great. Now, once I've got that, I might want to do some testing to make sure I'm reading the data correctly. But at this point, I've got a pretty clear idea that everything's compiling, everything's going according to plan. And again, if you're doing this at home, I want you to be running this stuff over and over and over again. Edit a line, compile, run the program. Edit a line, compile, run the program. Make sure that you understand the changes that you're making. Now that I've got all the data into the points array, what I can do is I can calculate if the point is inside or outside the circle. So if my circle distance to, and here's where I need to specify the points bracket I, oops, like that. Now we can either do less than or equal to or greater than. I'll just do less than or equal to. My circle get r. So we're going to check the distance against the radius as described in the README. And then we've got an else. Now, one thing I can do is I can print out two different long strings in both of them. Or another way I can do this is I can say, the strings are more or less the same. Remember that I've got to print out a message that looks like that I highlighted right there on line 48. The only difference between whether it's inside or outside is the word inside or outside. So I can say string outcome, and over here I can say outcome is equal to, well, if it's less than or equal to, that means it's inside. And here the outcome would be outside. Excellent. So now we just have to do one print statement. And this is going to be kind of cumbersome, but you only have to write it once. So we're going to start with a close parenthesis. And word to the wise, if you want to make this easier, what you can do is you can have methods for your point and circle class that convert them into strings. But since that's not like a necessary component to this project, we'll just do it here in line. So I've got the first parenthesis. I want to print out the x value of the point. So points I get x. Then we need a comma. Then we do the y. And then we do the close parenthesis, and then we say is, and then our message outcome, the circle, so we're going to say my circle dot get cx for it's the center, and then we say comma, and then we get the center y, and then we close parenthesis with a comma, and then we get this radius, and we close that off with a parenthesis and a new line and end. Excellent. So let's take a look. Let's type this out. Let's run it against one of our data files. Pretty good. It worked. Okay, now here's another tip. If I want to do all the data files at once, I can do a for loop on the command line. For I in, and I just give it the names of the files, do, and I'm just going to run the command over again. But oops, didn't mean to type that. I don't have to say, instead, if I want to get the variable I say $I. I'll say done. Finished. And I can count how many were done. 50, that's what I expect. And I can count how many were inside and how many were outside. And that seems about right. All right, so that concludes this video. I'd love some feedback on the audio quality, the video quality, and I'll post this online and hope to see lots of questions and answers in the forum.